Hello, boys and girls. All right, away we go. Chapter 5, Lesson 4, Factors and Multiples. And we've already talked about both of these words. Factors are the numbers that build other numbers. And then multiples, I always remember that as it's when you multiply a number. Okay, let's look at my little factory again. Do you remember that? Right? The factor is in the word factory, right guys? And those are the numbers that make the products that you put on the truck and you take to the people who need those products. Oh, that's a terrible truck. Okay, so factors build numbers and multiples are what you get when you multiply the number. So this first set of directions says, is the number a multiple of 8, right? Yes or no? So they did the first one for you. So let's look at number 2. Is 8 a multiple of 8? Well, can I multiply 8 times something and get 8? Of course I can. 8 times 1 equals 8. So, yes. Okay? Now number 3, is 20 a multiple of 8? Can I do 8 times something and get 20? Well, if you don't know off the top of your head, just write your 8s. 8, 16, 3 sets of 8 is 24. Oh, and look at that. We hopped right over 20. So, no to you. Okay? All right, so multiple when you multiply. So here we are down at number 7. And they just want you to, it says in the directions, list, what does it say? List the next 9 multiples of each number. Okay? Find the common multiples. So here's the first multiple of 6 is, of course, 6. 6 times 1. And here's the first multiple of 8. So we just have to write 9 more. Because you could do unlimited multiples, couldn't you? All right, so starting with 6, 6. And then what's 6 times 2? 12. All right, 6 times 3, 18. So we're just adding on sets of 6. 24, 30, right? 30 plus 6, love that one, 36. So we have 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times 5, 6 times 6. You see how they're all multiples of 6? Okay? So then we have 42, 48. Let's see, 1, 2, 3, 4, 5, 6, 7. We need 2 more because we have to do 9 of them. Okay, so then there's 54, and 6 more than that is 60. So you basically like wrote your 6 times tables, right? Those are multiples. So the next 9 multiples of 8. The first one is, of course, 8. 8 times 1 is 8. 8 times 2 is 16. Then 8 more than that, 24. Right? 8 more than that, 32. Do you see why these are multiples? 8 times 2 is 16. 8 times 3 is 24. 8 times 4, 32. What's the next multiple? Well, what's 8 more than 32? 40. We're counting by 8s. 48. Okay. What's 8 more than that? 56. 64. Okay, let's count them. 1, 2, 3, 4, 5, 6, 7. Oh, 2 more. Okay, 64 and 8 more. 72 and 80. Those are multiples of 8. Now, look at that word common. We've talked about that word before also. It means what's the same about them. Okay, what do they have in common? Let's see if they have any in common. There's one, right? 24, 30. Is that the only one? Keep looking. Oh, I see one more. Do you guys see it? It's in the 40s. See if you can find it. In the 40s, right? 48. Okay, 24 and 48 are common multiples of 6 and 8, meaning 6 times something equals 24, and 8 times something equals 24. Okay, multiples, 6 times 4, of course, and 8 times 3. All right, guys, excellent job. Okay, let's take a look at this one. This is gigantic looking, isn't it? The writing. Okay, tell whether 24 is a factor or multiple of the number. So is 24 a factor or multiple of the number? And so the answer is going to be either factor, multiple, or neither. Wow. So is 24, here's number 8 now. Is 24, we're going to start with factor. Is 24 a number that is in the factory that we can use to make 6? Is 24 times some number going to equal 6? That's a factor. No, 24 times no whole number will get you 6, right? Okay, that's not going to work. Let's try multiple. Is 24 a multiple of 6? So when you ask about multiples, you're thinking, can I multiply 6 times some whole number and get 24? Yeah, we just talked about that one, didn't we? 6 times 4 is 24. So tell whether 24 is a factor or multiple of 6. 24 is a multiple of 6 because 6 times a whole number, 4, is 24. You can multiply 6 to get 24. All right, let's go to number 9 now. Let's look at 36. So we have to think, is 24 a factor or multiple of 36? So let's go back here to factors. Can I multiply 24 times something and get 36? Well, 24 times 1 is 24. 24 times 2 is 48. Oh no, we go right over 36. So 24 is not a factor of 36. Let's see if it's a multiple. Okay? So what we're thinking here now, we are going over here to the multiple side of the squiggly line. Okay? So is 24, and we're thinking about a multiple, is 24 a multiple of 36? So can I take 36 and multiply it by something to get the product of 24? 36 times, well, 36 is greater than 24, right? So there is no whole number that I'm going to be able to multiply 36 by to get 24. So 36 is not a factor or a multiple. 36, you get neither. Okay? Beautiful. Let's keep going. All right. Oh, back to normal size type. This is at the bottom of the page, problem solving. Okay, here we go. Jody bought some shirts for $6 each. So it just says she bought some shirts for $6 each. Doesn't say how many, does it? Marge bought some shirts for $8 each. Again, we don't know how many shirts Marge bought either. The girls spent the same amount of money on shirts. What is the least amount of money they could have spent? Aha. So let's think. There's Jody and Marge. Sometimes I like to organize my thinking this way. And here are their shirts. Okay, so if Jody buys one shirt, she spends $6, right? If Marge buys one shirt, she spends $8. So what we need to find out is, since the girls spent the same amount of money on shirts, what is the least amount they could have spent? So is that the same amount of money? $6 and $8? No, that's different. That's two different amounts of money. All right, let's see what happens if they buy two shirts. Jody will spend $12. Margie, is that her name? Marge. Marge will spend $16. Now let's look at all these numbers. 6 over here. We have 6. No, that's not 6. That's not 6. 12. Nope. Nope. Okay, let's keep going. 3 shirts. Jody would spend $18 on 3 shirts because we're going by sixes, right? Each of her shirts was $6. 6, 12, 18, right? And then Marge, 8, 16. She spent another $8, so that's 24. Are any of those amounts the same yet? No, not yet. All right, let's see if they buy 4 shirts now. Jody will spend $24 on 4 shirts. Uh-oh, wait a doggone minute. Are you noticing anything, boys and girls? Jody bought 4 shirts for $24. Do you see another 24 here? Right there. So, let's go back to the problem. What is the least amount of money they could have spent? $24. Because it says the girls spent the same amount of money. It doesn't say they bought the same number of shirts, does it? They just spent the same amount of money. So what is the least amount they could have spent? $24. Now, Jody got 4 shirts. Margie only got 3 shirts. But they both spent $24 on shirts. Okay? Nice work, guys. And by the way, what you were just doing was listing multiples of 8 and listing multiples of 6. And then you found a common multiple. So you're geniuses. Geniuses, I tell you. All right, let's look at number 5. This is on the back, the review. And this goes back to Chapter 3, Lesson 5. Okay? All right, let's read it. There are 18 rows of seats in the auditorium. There are 24 seats in each row. How many seats are in the auditorium in all? Okay, you know what we have to do. Reread. Let me see here. There are 18 rows of seats. and 24 seats in each row. Oh, this brings me back to the olden days, right? 18 rows, 24 seats in each row. What is that screaming out at you? Multiply, right? All right, let's see. 18 rows of 24 seats. All right, 4 times 8. Let's see, 2 times 8 is 16, double 16 to 32. 4 times 1 is 4, plus 3, 5, 6, 7. Okay, we have a placeholder situation there, right? Done with you ones place. Let's go to tens. 2 times 8 is 16. 2 times 1 is 2, plus 1 is 3. What do we do with those partial products? Add them up. 2, 6 plus 7. Let's see, 6 plus 6 is 12, so 6 plus 7 must be 13. 3 plus 1 is 4. 432. Okay? Beautiful work, boys and girls. Do the rest of your homework and have an awesome night.